Okay, so today we're going to dive deep into something that I'm pretty sure a lot of you out there, especially those prepping for senior software engineering interviews, are thinking about, and that's microservices. Everyone talks about the benefits, but when you get into an interview, it's the complexities and trade-offs that really get scrutinized.
Yeah, absolutely. When you're at that senior level, they don't just want to hear you parrot back textbook definitions. They want to see that you've wrestled with the practical realities of distributed systems.
Exactly. So today we're going to break down those areas where microservices really change the game. We'll give you the tools to talk about these things intelligently and confidently, like you really know your stuff.
We'll cover how microservices impact developers on a day-to-day basis, the potential downsides of technology sprawl, the often overlooked cost implications, the challenges they can bring to reporting, the complexities of monitoring and troubleshooting in distributed environments, the crucial security considerations, how testing evolves in a microservices world, that ever-present latency challenge, and the really interesting puzzle of data consistency across multiple services. Ready to get started?
Let's dive in. Let's start with something anyone who's worked with microservices has probably experienced firsthand, the developer experience. Just imagine trying to run a bunch of different services, maybe even a dozen or more, on your local machine. If those services are using something like the JVM, resource contention can quickly become a real issue.
Right, you might find your machine handles 4 or 5 JVM-based services okay, but try to run more than that and things start to get really slow. Memory and processing power become major bottlenecks.
That makes total sense. So what about developing directly in the cloud? It sounds like a great solution, unlimited resources, theoretically, but then wouldn't that negatively impact your feedback loops? Waiting for deployments and builds in a cloud environment could really slow down that rapid iteration we depend on for efficient development, right?
That's the trade-off. And it also has interesting implications for team dynamics. You might want to limit the scope a developer works on to make things manageable, but then a lot of organizations push for collective ownership.
So how do you really foster that sense of collective responsibility if your local development setup makes it difficult to run and test a lot of services at once? It's hard to contribute to a service you can't even get running on your own machine.
Right, it's a balancing act.
Yeah.
Now, let's say you've got that local development situation figured out. You're then faced with what often feels like an overwhelming number of technologies in the microservices world. All those different languages, runtimes, databases, tools. It's easy to feel lost.
Definitely. And then there's the danger of what I've heard called shiny object syndrome, the temptation to adopt every new technology just because it's cool or seems like it's made for microservices, even if you don't actually need it.
It's important to remember that while microservices allow you to use a variety of technologies, it's not a requirement. You have the option to use different languages or databases for different services, but it comes with a cost.
That's a crucial point. Just because you can have one service in Node.js, another in Go, and another using a NoSQL database doesn't mean you should. You need to carefully consider those benefits against the added complexity it brings to your team's expertise, operations, and integrations.
Absolutely. Think about the time your team will spend learning and maintaining all these different technologies. That's time they could be spending building features and delivering value. And when it comes to infrastructure, something like a full-blown Kubernetes cluster might be overkill if you're only running a few microservices.
Right, a gradual adoption of new technologies as your architecture evolves makes a lot more sense.
A good rule of thumb is to aim for a level of familiarity across your team, where any small group could understand and operate a particular technology.
Okay, that makes a lot of sense. Let's shift gears and talk about something people are often surprised by: cost. There's this assumption that microservices automatically lead to cost savings, but that's not always the case, at least initially.
The initial increase in infrastructure costs is often underestimated. Instead of one application, you're now running multiple independent services. More virtual machines, more containers, more network traffic, potentially more storage. It all adds up. And then there's the cost of the supporting infrastructure for orchestration, monitoring, and logging across all those services.
And it's not just the infrastructure, right? There's also the impact on development speed, at least in the beginning. Teams have to learn new architectural patterns, technologies, and deployment processes, and that learning curve can slow down feature delivery.
Exactly. If a company is focused on immediate cost reduction and sees IT as an expense, they might miss the long-term benefits of a well-implemented microservice architecture. However, microservices can absolutely increase profits in the long run by enabling faster innovation, the ability to handle more customers, and more efficient parallel development.
So it's more of a strategic investment with potential long-term gains, not a quick fix for budget issues.
Okay, let's move on to something that can get a lot more complicated with microservices. Reporting. In a monolithic application, generating reports usually feels pretty straightforward. All your data is in one central database with a consistent schema.
Yeah, you have that single source of truth. It makes it easier to run queries and aggregate data. Even if you're using read replicas for performance, the underlying data structure is pretty much unified.
But with microservices, that nice centralized data model goes out the window. Each service manages its own data in its own database, often with different schemas that are optimized for its specific needs. Trying to generate reports that span multiple services becomes a real challenge. You lose that easy-to-query database. Modern reporting in a microservice world often involves things like real-time data streaming to data warehouses or data lakes, or setting up specific data synchronization mechanisms to consolidate information for reporting. It's a different way of thinking and often requires new data management technologies.
Okay, so reporting definitely gets more complex. Now, let's talk about what happens when things inevitably go wrong, which they always do. Monitoring and troubleshooting a monolith can be tough enough. I can't even imagine how much harder it gets with dozens or even hundreds of independent services.
It's a huge jump in complexity. In a monolithic environment, you're usually monitoring a few instances of the application. If something breaks, the logs and metrics are centralized, making it easier to find the problem. But with microservices, a failure in one service can have these ripple effects across the whole system. You need to understand how far those effects will reach, what other services will be impacted.
And then there's the challenge of making sense of all that data. If one process in a monolith is using a lot of CPU, it's a pretty clear sign of a problem. But when you have hundreds of microservice instances running, how do you know what's normal resource usage and what's a real issue?
That's where distributed systems observability comes in. It's a set of tools and practices designed to give you visibility into the behavior of your distributed applications. This includes things like sophisticated logging, distributed tracing to follow requests across services, and comprehensive metrics dashboards that show you the health and performance of your entire system. It's about moving from just knowing if something is broken to understanding why and how to fix it quickly.
All right, that makes sense. Let's move on to security. Spreading your application logic across multiple network boundaries definitely creates a bigger attack surface.
Yeah, the increase in network communication between services is a key factor here. In monolith, a lot of interactions happen internally, within the same process. With microservices, more and more data is being transmitted over the network. This creates more opportunities for that data to be intercepted or manipulated.
So you can't just rely on traditional perimeter security anymore.
You need to secure the communication channels between your services. Protecting data in transit through encryption becomes super important, and each microservice endpoint needs to be secured to make sure only authorized services or users can access it. It's a distributed security model that requires a layered approach and a lot of careful thought about potential vulnerabilities.
Okay, let's talk about testing. I'm guessing the shift to microservices requires us to rethink our traditional testing strategies.
Absolutely. This is a constantly evolving area. In software testing, there's always this trade-off between how broad your tests are and how complex they are. End-to-end tests that cover the entire system can give you a lot of confidence, but they're often slow to run, difficult to set up and maintain, and a real pain to debug when they fail.
And it seems like those end-to-end tests, which try to simulate real user interactions across the whole system, would become exponentially more complex in a microservices environment.
Exactly. Imagine trying to orchestrate an end-to-end test that involves multiple microservices that are deployed and configured independently. The setup is super fragile, and you're more likely to get false negatives because of environmental issues, not actual bugs in your code. As your microservice architecture grows, the reliability and effectiveness of traditional end-to-end tests tend to decrease.
So what's the alternative? How do you ensure quality in a microservices world if end-to-end tests become less practical?
We're seeing a shift towards different testing strategies. Contract testing, where you focus on verifying the agreements between services, becomes really important. You're making sure that services can communicate with each other the way they're supposed to. Testing in production, using techniques like canary releases and A/B testing, lets you validate new deployments with real user traffic in a controlled way. Progressive delivery techniques, like feature flags, also help reduce the risk of new releases. These approaches acknowledge the distributed nature of microservices and the limitations of those traditional monolithic testing strategies.
That's a big change in how we think about quality assurance. All right, let's tackle a concern that's probably on everyone's mind: latency. Moving from a self-contained application to a distributed system where services communicate over a network seems like it would definitely add delays.
That's a sharp observation. Operations that used to be simple, in-memory functional calls within a monolith now involve serializing data, sending it across a network, and then deserializing it on the other side. Each network hop adds some overhead, and those little delays can add up to increased end-to-end latency.
So how do you minimize that potential performance hit?
It all comes down to incremental migration. Don't try to decompose everything at once. Make small, targeted changes, and then carefully measure their impact on latency. You need to have distributed tracing tools in place to track requests as they flow through your microservices so you can identify bottlenecks. And most importantly, you need to define service-level objectives, SLOs, for latency and continuously monitor against them. Sometimes a small increase in latency might be acceptable in exchange for the benefits of modularity and scalability, but you need to make those decisions consciously and based on data.
Okay, that's really helpful. Finally, let's talk about data consistency. This feels like a really fundamental shift from how we typically manage data in monolithic applications with their relational databases.
Absolutely. In a monolith, you usually rely on ACD transactions provided by a single database to ensure data integrity. But in a microservice architecture, where each service often has its own database, getting that same level of transactional consistency across multiple independent databases becomes a huge challenge. Traditional distributed transaction protocols can be really slow and complex.
So that safety net of atomic transactions is basically gone with microservices. What takes its place?
It requires a fundamental change in how you think about data. Concepts like sagas, which are basically a series of local transactions in different services that are coordinated to achieve an overall business goal, become really important. You also encounter the idea of eventual consistency, which means the system might not always be in a perfectly consistent state, but it will eventually get there. This requires thinking carefully about how to handle potential inconsistencies, and often means designing your system to be more resilient to temporary data discrepancies. Gradual decomposition allows you to experiment with these patterns and understand how they impact your data consistency requirements.
Wow, that's a lot to take in. So we've covered the core complexities of microservices, the challenges for developers, the risks of technology overload, the potential cost increases, the difficulties of reporting with distributed data, the intricacies of monitoring and troubleshooting, the increased security concerns, the evolving approaches to testing, the potential for increased latency, and the big shift in managing data consistency.
Exactly. And for anyone preparing for a senior-level technical interview, showing that you understand these complexities, the trade-offs involved, and potential ways to mitigate them is really important. It shows that you're not just excited about the idea of microservices, but that you have a practical understanding of what they mean in the real world.
So, as you continue your interview prep, here's something to think about. Given all these complexities, what strategies, beyond just technical skills, can a senior software engineer use to successfully navigate the challenges of a microservice environment on a real team? Things like effective communication, clear architectural governance, and fostering a culture of shared responsibility in a distributed system. It's not just about writing code, it's about the whole ecosystem. Thanks for joining us for this deep dive.